Hi everyone, today I'm going to discuss about M-group analysis. First of all, let's look at what you mean by molecular weight. The molecular weight of a molecule is the sum of weights of all atoms which make up the molecule. We all know obviously the molecular weight is the sum of weights of all the atoms that is present in a molecule. Then we can express this molecular weight in different terms. Let us look what are the different terms in which a molecular weight can be expressed. The first one is the number average molecular weight. The number average molecular weight is expressed as Mn. The next one is the weight average molecular weight represented by Mw, Z average molecular weight represented by Mz, and the last one is the viscosity average molecular weight expressed as Mv. Okay. Next, we are going to discuss about the determination of number average molecular weight Mn bar. In practical, number average molecular weight may be determined by the following method. Various methods can be employed to find the number average molecular weight. They are, the first one is the cryoscopic method. In the cryoscopic method, we calculate the depression in the freezing point. The second method is the ebullioscopic method. In the ebullioscopic method, the thing that is being measured is the elevation of boiling point. The third one is the osmometry. There are two types of osmometry. The first one is vapor phase osmometry and the second one is membrane phase osmometry. And the last one is the M-group analysis. The above three are being discussed already, and I'm going to discuss about the last one, that is the M-group analysis. Then let's get started. First of all, let's look at what you mean by M-group analysis. The M-group analysis is a chemical method used for calculating the number average molecular weight of polymer sample whose molecule contains reactive functional group at one end or both the ends of the molecule. So, the method of M-group analysis can only be employed for those polymer chains that have the functional group, the reactive functional group at one of the ends of the polymer chain or both the ends of the polymer chain. Such polymer molecules only shows the M-group analysis. The number average molecular weight of such polymers can only be measured by using the method of M-group analysis. Before going into detail about the M-group analysis, let's look at some of the terms regarding the M-group analysis. The first term that has to be discussed is the functionality. Functionality, it is the number of reactive functional group present in the macromolecule. Okay, so the functionality means it is the number of functional group, the number of reactive functional group present in a given polymer chain, in a given single polymer chain is called as functionality. For example, let us consider the carboxyl terminated polybutadiene represented as CTPB and hydroxyl terminated polybutadiene represented as HTPB. These molecules have carboxyl or hydroxyl group at their respective ends. Therefore, for every two functional groups identified in a sample of polymers, one molecule has to be present. We know that in the two polymers, carboxyl terminated polybutadiene and hydroxyl terminated polybutadiene, there are two carboxyl or two hydroxyl group present in the polymer chain. So, if we identify any two functional group in a given polymer sample, we can say that there is one single polymer chain present. That is, for every two functional group that has been identified, there are one polymer chain present. Thus, the functionality of CTPB, carboxyl terminated polybutadiene and hydroxyl terminated polybutadiene, is said to be 2, as each molecule possesses two reactive functional groups. Therefore, the functionality of this molecule is said to be 2 because they have two functional groups present in the polymer chain. Apart from hydroxyl and carboxyl, several other N groups such as aldehyde, amino, ester or methyl can possibly be present. The functional groups other than hydroxyl or carboxyl functional group, other functional groups such as aldehyde, amino group, ester group or methyl group also shows N group analysis. Okay, we have discussed about the functionality. And the other term we have to know is the functional group equivalent. Chemical methods are employed to find out the total number of functional groups present in a given weight of sample and is expressed as functional group equivalent per 100 gram. We have said that the functionality means it is the number of functional groups present in a single polymer chain, that is functionality. Functional group equivalent means for a given weight of the sample, for a given sample, the number of functional group present, the total number of functional group present in a given amount of polymer sample is called as functional group equivalent, and it is expressed in functional group equivalent per 100 gram. From the knowledge of functional group equivalent and functionality, the average molecular weight can be calculated by using the equation. We came to know about the functionality and the functional group equivalent. From these two terms, we can find out the number average molecular weight mn bar is equal to functionality divided by functional group equivalent. Next is the chemical method used to find the functional group equivalent of a polymer for a given polymer. For example, in this case, let us take the polymer carboxyl terminated polybutadiene. Can be determined by dissolving a known quantity of the polymer in a mixture of ethanol and toluene and titrating against alcoholic potassium hydroxide solution. So, the functional group equivalent can be determined by the chemical method. In this case, we take the example of carboxyl terminated polybutadiene. The carboxyl value of carboxyl terminated polybutadiene can be determined by dissolving a known quantity of polymer. A known quantity, say usually we take less than 1 gram of the polymer sample is being dissolved in a mixture 1:3 mixture of ethanol and toluene, and this solution is then titrated against alcoholic potassium hydroxide solution. Let us look at the procedure. First, commercial grade ethanol is distilled and neutralized with a dilute solution of potassium hydroxide. In the second step, 1:3 mixture of ethanol and toluene is produced. A precisely weighed quantity of carboxyl terminated polybutadiene sample is dissolved in ethanol toluene mixture. Usually we take the polymer sample, the weight of the polymer sample will be less than 1 gram. This polymer sample is being dissolved in ethanol toluene mixture. Then this solution, the solution containing the polymer and the ethanol toluene mixture is then titrated against alcoholic, about 1 normal alcoholic potassium hydroxide solution using phenolphthalein as indicator. The endpoint of the titration will be the appearance of slightly pink color. From the titer value, we can find the carboxyl equivalent per 100 gram will be equal to Vn by 10W, where V is the volume of potassium hydroxide consumed, whereas N is the normality of potassium hydroxide solution, and W is the weight of the sample, polymer sample that we have taken. Okay, from this we can find the carboxyl equivalent per 100 gram, carboxyl equivalent value of a polymer of the carboxyl terminated polybutadiene. Okay, this is the chemical method used for finding the functional group equivalent, taking carboxyl terminated polybutadiene as an example. Next, this method can be reliably used for samples consisting of linear molecules with a determinable N group and for those obtained by a non-polymerization mechanism without side reaction. Presence of side reaction causes errors in the calculation of the functionality. Then one of the major drawbacks of this method, the method of N group analysis, is that only those polymer chain can be measured. The only linear polymer chain can be measured by this mechanism, and also we have to know the polymerization mechanism beforehand to apply the N group analysis. If the polymerization mechanism produces any side reactions, then this method cannot be employed because the presence of side reaction causes errors in the calculation of the functionality. Therefore, this method cannot be employed for the non-linear molecules and also for those polymers whose polymerization mechanism gives side reactions. Then this method can also be used to find the average functionality of the polymer sample. From the previous equation, we know that the number average molecular weight is equal to the functionality divided by the functional group equivalent. By simple rearrangement from this equation, we can find the functionality. From this equation itself, we can find that the functionality will be equal to the number average molecular weight into functional group equivalent. Okay. For this functional group, equivalent of the sample is obtained by chemical analysis, and molecular weights can be determined by any other method such as osmometry. The functionality, we can calculate the functionality of a polymer molecule by the N group analysis method. The only thing we have to know is the molecular weight has to be determined by any other chemical method, any other method such as osmometry, and the functional group equivalent should be calculated by the chemical method that we had discussed earlier. Okay, that's all about the N group analysis. Thank you for your listening. Thank you so much.